my talk for you guys that know me is, I get asked this all the time, why is the Forest Service R&D working down on the farm? This is the world you're probably well versed in. You see the dark green, and that's the forest land areas. By the way, my training was from up in Wisconsin, Pacific Northwest, NC State, so I had the best of both worlds in that. But if you take the negative of this picture, this is the land that we work in. These are the American agricultural croplands that all of you in here depend on. Right smack in the middle of the heartland is that National Agroforestry Center. So before I answer the question, why is the Forest Service working down in the land, I always like to, before I explain a solution or an answer, I like to explain the problem. It goes back to the 1930s, the Dust Bowl days. Forest Service was located in Lincoln, Nebraska, and essentially, this was the landscape out there. Forest Service came in, no trees at all where trees would grow, and soil will blow. One of the largest tree planting programs there was. Pete Rosopoulos' dad actually was part of the tree planting crew out in this. So a long history of trees being planted out in windbreaks to reclaim the soils. But we're dealing actually with a very, very different situation out there in agriculture right now. We really want a lot more from these agricultural lands. Society is demanding from that farmer out there who's trying to make a profit. We've got the food, feed, fiber, but these lands are now being targeted for biofuels, which is causing a lot of conflicts. A high variety of bioproducts. We expect these lands to help us support biodiversity, healthy soils, clean water, healthy landscapes. So essentially a farmer is required to produce many of these services now, because we want it all. But the problem is with the growing population, we're going to want more of it. And as many of you that deal with the climate change, we already know that there's a tremendous uncertainty of even being able to realize the agricultural potential under current conditions, let alone those that are projected. You guys have done a lot of work with trees and forests with regards to maybe carbon dioxide and the temperature change, possibly precipitation change. One lucky thing about being in Nebraska, I don't have to worry about sea level rise. You guys might be doing that with your forest research. But this one over here, this is the one that's really kicking us in the shins right now, extreme and erratic weather events. And Tom from Illinois, tornadoes, we're used to it. You guys, hurricanes. Extreme weather events from too much water to too little water. The National Climate Assessment essentially has stated that not only have we seen an increase in this trend, they're expected to increase further in the next 25 years with increasingly negative impacts on most crops and livestock. So yeah, even in the Forest Service, this is stuff that's going to be hitting you guys directly. And I like ecological disasters because it makes it easy for me to prove a point. So it's not like I'm looking for the extremes. 2011 through up to now has been very nice for my PowerPoints here. Southwest, extreme drought. At the same time, outside my back door in Nebraska, the floods along the Missouri River, very, very productive agricultural lands. Loss of productivity during the flood. Longer lasting is when those waters recede. Massive damage up and down the Mississippi River basin where those crops are. Please recognize the irony of irrigation equipment in a floodplain. You sort of have to think about land use, land capability, trying to match those two better. What else do you see in that picture? Should be something really obvious.
Trees.
Trees. What about the trees?
They're green.
And the land's there. 2012. Who could forget 2012? Well, maybe you guys in North Carolina. It's the only time you've ever gotten a really profitable corn and soybean crop here, because the rest of us, man, let me tell you, it was one of the most massive, and we're still feeling the impact of 2012 drought. That's what the land looked like. The corn didn't make it. The land's very clean, very bare, not much residue. Remember this. 2013 started out with floods. That same area by July and August, severe drought. California the same way, one of the wettest springs, severe drought by summer. 2014, nationally it might be looking a little bit better. Corn Belt there. I've actually driven through many dust storms already, local dust storms. Problem we've had, you probably heard about the Arctic Vortex. I think we kept sending you winter all along there. Well, essentially we had very prolonged periods up to 50-mile-an-hour sustained winds. This is one of those sites. Essentially what you have back there is a winter wheat crop that's been blown out. A blowout is when the topsoil is essentially just blown away. What can you see here? Can you raise your hand?
More trees.
It's a living snow fence. It's actually put in place to keep the snow from going out on the road. What else do you see?
Green.
Green. So essentially the farmers and we as a U.S. nation, we're playing with loaded dice right now. For a farmer to operate, it's more likely for them to be able, for them to roll extreme events than it's to roll a normal year. The way they now crop and look at their profitability is maybe one profitable year out of 4 or 5. With the price of corn up till this past year, that was a way of doing things, but it has other ramifications for us. What if you roll a bad combination? I'll pick on Iowa because I knew better than to pick on Illinois. Any Iowegians here? John Gordon's the best forester there ever was. The best foresters are actually from Iowa.
That's what I keep telling people.
And that they do.
Which is Jeff's dad, who's a forester at the.
Forestry extension.
Yeah, no, seriously, they are some of the best foresters, particularly working with animals in that. But essentially, 2012, the worst drought since 1936. 2013, the wettest spring in history. This is a newly planted cornfield on the 4th day of a rain event. Think about that. That's a beach. Yeah, it's a real beach. Current productivity impacts obvious. What's not? Long-term productivity. Next question is for the soil scientist here. The average field erosion for the counties in Iowa was more than 5 tons per acre. Why is that number significant? What is that called?
Bad.
Bad. That's called a T level. A T level is that tolerable level that when you produce corn can leave your field because soil can reform to that extent. Anybody in here believe that? It's not even close. In fact, Rick Cruz at Iowa State is showing that it's probably 100 times too much. I'll sort of walk a line anywhere it's 10 times to 100 times too much. So in other words, they're losing more soil in one rain event than will be formed back there. So this impact of this erratic weather goes farther than just the loss of the crop. Now what happens when you roll a really bad combination of 2012 and 2013? 2012, if you remember those crops were there, you added the nitrogen, the crops didn't grow. Very high nitrogen contents. In fact, the soil consultants essentially said you do not need to fertilize for your 2013 crop. But what happened, before the crops actually came up and even took up any of that nitrogen, you had the 2013 rains, which had a very high erosion. Combine those two, we had massive local issues. Drinking water, swimming, not just nitrates in the water. The nitrogen was pumping off of one field. Let's see, 55 gallons per minute. The amount of nitrogen coming, I don't have the exact figure of the number, but essentially more nitrogen coming off in that one event than what would normally come off in a year. Not only do you have those local issues, but essentially they accumulate, and that's what creates your dead zone issue. So I always like to say, well, when climate's kicking your butt, you don't let it kick your butt for many years, you start hedging your bets. And the way we're doing that in agriculture is we're trying to create what's called this climate-ready toolbox for ag. Again, from the NCA, it's talking about these losses and degradation that you saw there are only going to increase as extreme events increase and less innovative conservation methods are implemented. A lot of the people that I work with, they're looking at many activities. And for those of you from Iowa or have worked with use of conservation tillage, crop rotations, definitely fertilization, the timing, placement, etc. These are all common sense. You have to have all of those. Essentially, when a farmer, he or she puts their land together, they're utilizing many of these pieces. But what you should recognize, most of these are not what I would call innovative. Maybe some of the mixtures might be, maybe some of the crop species. Right now we're in sort of, I think sort of in a slump. They're pretty much into corn mentality. I have heard the price of corn has gone down. Well, I think it got up to 502 right now, which means there's a little bit more soybean going in. So you can tell this extreme event, the risk hasn't hit them enough to do business out of the ordinary. Things are pretty much business as usual. We'll just wait and see if we get kicked in the butt again. And so what they have started looking at, and essentially why I got called to Washington, was what about agroforestry? And essentially it is a piece of the puzzle. It is a piece of the menu that farmers should have access to on their landscapes to try to start building in resilience to these events. It's not to displace the agriculture, it's to build resiliency into that landscape. So I have found one of the biggest issues we have in the Forest Service, ARS, probably all the sciences, there's baggage with communication. In 1999, I had to go to Washington, D.C. to recharter my unit, which had been zeroed out in the 95 event, which for the youngsters don't realize, that was, what was it? That was probably, we lost half of Forest Service researchers, I think, in that cut. But anyway, they said, we really like what you do, Michelle, but we don't like you doing agroforestry. And yeah, I was a little perplexed, and I explained pretty that I can't go to Washington because I can't keep a straight face. I kept a straight face here. And I said, I don't do agroforestry. I do tree-based buffer technologies to restore ecological functions on private lands. And they absolutely loved it, so that's what I chartered. So it's, what I have found is people have different perceptions of a term. And I've always been a very much Southerner in that I look at that term and it's what you meant. And I'm very open to the term, some people aren't. So I start off by explaining what agroforestry is, and the best way to do it is what it isn't. It isn't afforestation. It's afforestation-like, but it's not afforestation. It doesn't change the land use. It's actually there in support of agriculture. It very much involves intentional mixing of agricultural and forestry elements to help build a more productive, healthy, and resilient operations. Different paradigm shift. Instead of maximization of yield of corn, you're optimizing the services that you require from the land. You're trying to avoid those highs and lows that can occur under those erratic weather events. Now there's 5 types of agroforestry practices. I'm not going to get into them in any depth, but just to give you a feel, there's many different ways of assembling buffers to meet the objectives. And you can do this either by alley cropping, civil pasture, forest farming, riparian forest buffers, and windbreaks. And yes, I can count, there is 6 up there, but it's real hard with a hand with just 5 fingers. We've actually got an emerging 6th category where we've had quite a bit of demand probably since 2006, when towns of 10,000 were required to treat their stormwater with EPA. And essentially these towns were looking for cheaper ways of meeting these demands, and instead of gray infrastructure, green infrastructure. So essentially we worked at adapting many of these practices to give them other services and stormwater treatment. There's a lot of interest in using riparian buffers to to augment feedstock production, I should say. So it's not really for traveling fuels as much as for combined heat power systems. Agroforestry, if you will, is a designer landscape feature. So think of it in your mind. You're using forest science to create on that landscape small landscape features in that agricultural matrix. They provide multiple benefits simultaneously. And I'm going to get down to this. It's all about the right trees in the right place for the right jobs. When I first came on to NAC, everybody's working on tree improvement. Everybody's saying we got to put them everywhere. And I was saying, no, you know, where do we not put trees? That's as important as figuring out where they do need to be put. With regards to climate change, really interesting. agricultural group, they're now recognizing that agroforestry is sort of a Leatherman within the climate change integrated toolbox for agriculture. And I know with this crew it's not as much fun, but when I was talking to the House and the Senate staffers, and the majority of them are such cute young things, I had to ask them, did they know what a Leatherman was? You know, so I will ask, just raise your hand. And better yet, who's got one in their back pocket?
We used to have them. Lance bought them for us 10 years ago, but we lost them.
Okay, essentially one tool that does many, many things, because, I mean, you really need to see this analogy, and this is why agroforestry's been picked up on. Provides numerous services with regards to mitigation, and in particular, it provides adaptation services while they're producing other services. And this is very, very important because people really don't care about this. They're caring about, you know, bottom line dollar or bottom line value, maybe $100 million. So these practices need to be doing these other things at the same time. If they're in place with a little bit forethought in design, you can optimize these services. And I'm not going to talk much about the carbon sequestering potential, but it's to give you an idea. At one time with the Chicago Climate Exchange, the Farm Bureaus actually were making payments to farmers based on conservation tillage or conversion from conventional to conservation, and they based it on a rate of carbon being sequestered in the soil. And if you looked at, say, about 254, 100% of that being turned into conservation tillage only. So this would be the most extreme, going from conventional to conservation. Pretty good size of metric tons per CO2 being sequestered, and this is calculated on a 50-year basis for that. If you were to put in 3% for windbreaks, which after 50 years might take up about 5%, the reason I use that 3%, you use 3% windbreak per field to enhance crop yields. So essentially you get a greater yield production than the land taken out of production from that windbreak. So that prescription is not based on carbon. You can see that you substantially increase that carbon. Is that going to mitigate greenhouse gases? I think personal choice on not driving your car one day is probably better. But if there is a market for these credits, that farmer will have greater incentive to put these plantings in because they do other jobs. So of all of these, I'm going to concentrate now on only the reducing the threats and enhancing the resilience. That seems to be really where the interest is in Washington. They're trying to figure out what might they pay farmers for instead of paying them crop insurance. Okay, why would I pick that one? And again, I'm thinking just very pragmatically. I realize it's lunchtime, but it's one of those things to keep you guys awake.
Well, is it because they're paying out a lot of money in crop insurance with the droughts and different events that?
Well, that's why Washington likes it, but why would a farmer be more concerned? If he's looking at any of these services, this is probably the most important.
Just reducing.
If the crop isn't going to be there, he's not going to be doing anything else. So really, this is where we need to be starting. A lot of the research emphasis and a lot of the push that I've gotten in several of the Hohenstein projects that I've been involved in is measuring these things up here. Not realizing that really, if you're going to sell these to the farmers, you also really need to look at that adaptive capacity of these systems. Simple ecological theory, risk management is difficult in monocultures and annual-only systems. That's a lovely viewscape. If we were in Iowa, it might be a bidiverse viewscape, and you'd have
Corn, beans.
beans, yeah. And essentially the whole principle of agroforestry is just to be mixing in those woody plants to have crop diversification, really get that structural and functional diversity. And what we do know from agroforestry systems, here's obviously more trees than you'd expect to see out on some farmscapes. The amount of diversity, the impact of the diversity is far greater than the land that's taken out of production. These are the four main functions that I try to present to people to explain how the system works. So just jumping straight into it. Microclimate modification out in the Great Plains in particular. We've worked with Canada down to Texas on this, and essentially windbreaks are known to increase yields due to that wind protection. We do an earth wellness where we reach out to probably 500 fifth graders doing 25-minute experiments. And And what I always like to say is, these trees break wind. Which is really good if they come from a Catholic school, because then they back windbreakers. But really, it just breaks the power of the wind. Evapotranspiration is reduced. Quality of some of the crops is enhanced without the abrasion. In alley cropping systems, again, by reducing the evapotranspiration, higher grain yields in alley-grown wheat during drought compared to control. For forage, essentially air and soil temperatures too cold or too warm for forage can be favorably modified by silvopasture systems to extend that production. If you can extend that production, that's dollars in the farmer's pocket. Essentially it's cost to bring in external feed. This is an interesting one. Higher levels of CO2 have been found to reduce forage quality, which means you got to produce more, they got to eat more. As the quality go down, you have to produce quantity, so you've got a dilemma there. Shading studies, not silvopasture studies yet, but shading studies have been found to improve forage quality, in which case if you have a silvopasture system where you've got that shade, you may well be able to mitigate this adverse effect of increasing CO2. We don't know. Some research is ongoing. Microclimate modification for livestock. November, a blizzard hit Nebraska, 100,000 head of cattle dead. Essentially the ones that died were going into the little stream area, and a lot of it was mainly from suffocation and some cold exposure with it. One event. Heat stress on livestock, about the third day you're starting to see death. So in other words, with these weather extremes, and it's going to be fluctuating both ways, what do you do? We know up in the north, livestock shelter belts increase that feed efficiency and milk production in the winter. We know in the south, cattle's provided shade reach their target body weight 20 days earlier than those without shade. I'm going to throw that out to you again. Just think in terms of yourself. Why? If you're out in the sun and then there's shade. Respiration. You don't go out in the sun to hot, so essentially you extend that feeding session. Habitat diversification. This was the, now as acting director, I'm finding out, boy, those people really do a lot of work that I really don't like. So the fire du jour was to provide Larry Stritch with some information on the services trees can provide to supporting bee populations. Big time. And actually, we've worked with Xerces Society, who's one of the big pollinator groups. And Agroforestry can provide critical little refugia, particularly for the ground-dwelling native pollinators. They can also provide some of the critical early flowering food sources, too many F's there, that's actually very beneficial to many of the fruit crops like, I was going to say blue honeysuckle is one of those crops right now being used by a lot of more small resource farmers. The earlier they're pollinated, the better they're pollinated, the better the crop production. But you need to have some type of flowering thing there. Some of the trees and shrubs provide that. We've also had research, natural enemies to pest crops can be enhanced. Habitat diversification for connectivity. This is our landscape. So you can see where this becomes highly, highly critical. Very much for travel corridors. Wanted to get a southern example here. So this is, I get to slip into my old southern. This is Louisiana black bear. And it's been found by researchers that essentially in the lower Mississippi alluvial valley that are massive grain areas to almost vie with Illinois and Iowa monoscapes, that the bears use these corridors just for everyday survival, foraging distances, and reproductive capacity. You can see where these corridors will probably become critical when they need to get out of Dodge, as that system becomes less favorable. These would be the travel corridors where they could go. Extreme weather events. Leave it to those 2011 floods to prove a point. Essentially, the bear climbed up in the trees, and they survived during the floods up in the trees eating the leaves. We don't know if they can survive up there longer than 5 days. We've only replicated this experiment once. I'm trying to get an NSF grant to replicate it a couple more times. I'm sure nature's gonna help me on this one. Maintenance and protection of soil, I mentioned the Dust Bowl days. Please don't think that that is over. I have driven through many a dust storm. They're definitely more localized, but they're just as lethal. When we have a blowout essentially is the blowout of all that surface productive soil out there, and it's hard to get a crop back in. Under the 2 degree C increase in annual temp, you could increase erosion by 15 to 18%. If these systems are in for right now for crop yield, they'll be there if an event occurs. Maintenance and protection of water. I think you guys know that one pretty well here in North Carolina, because there's been some great riparian work here. Both riparian buffers, which I always call the last ditch defense because it's to intercept that stuff coming off. I like more upland strategies where you try to keep the nutrients in place, alley cropping, keep the nutrients cycled within the site. And then you get down to really hedging your bets. And agroforestry systems really have tremendous potential for the small and limited resource farmers for really providing diversified income sources. Actually not this small and limited, because some of the most successful, particularly for silvopasture, are pretty large scale now. But essentially you're going to build that risk and resilience by providing both annual and those longer term but higher value income opportunities. And for the Southeast, there's a tremendous potential for silvopasture. Evan Mercer can probably tell you of many of the silvopasture activities going from, well, you're involved with the Agroforestry Working Group for the Chesapeake down to the Virginia. And I've got him working on several other aspects of this. I see this one as being a very promising area for the Southeast. We're not talking about the prime corn soybean line. We're talking about the not prime. So not prime, I mean, not only do you get a poor crop, you get a pathetic crop. So you're not displacing good agriculture. And these are areas that are already experiencing extremes and have been, but yet people have persisted to try to get that corn profit. This is out at the Center for Environmental Farming Systems that Evan's involved with, and Fred Cubbage, Paul Mueller. They had the foresight to set up an alley cropping system that is statistically designed. You got to understand in agroforestry, this is the premier plot for us out here. Statistically designed, is now at a functional level, is in cropping procedures, and we're doing a lot of research on this plot here right now. The trees were planted in 2007. It was kept in its corn-soybean rotation, not unexpectedly for that area in Goldsboro. You had drought, then flood, drought. And like I said, essentially that poor to pathetic net returns. You know, but farmers sort of persist because you've got what? Farm payments. At the same time, during all this, tree survival at 2011 was 88% plus. So you know trees can grow there. They can do well. They can do work for us. This is just a picture to show you the site out there. For those that have not been out to the site, Evan, I think the ticks and chairs should be getting really high up there, out there. I'm sure they could use some help out at those plots. But you can see what we're looking at here, and the things that are being explored is that width of the alley, how you manage the trees in the row. Do you have a 3-row? Do you have a 2-row? When do you thin? What are the economics of these options? What are the economics of transitioning from that annual crop then into silvopasture? Or do you use it instead of transitioning out of these corn soybean into maybe herbaceous biofeedstock? The one study we're looking at here is what are the greenhouse gas dynamics in these systems. We have very, very little research in agroforestry systems. By common sense, you know, the more complex the system, the tighter the cycling of it, it should reduce those greenhouse gas emissions, but we don't know. We're very, very lucky to have Dr. Alan Franzlupers with ARS up here now in Raleigh. Kurt, have you met him at all, with any of that? Perdita? I know he's on the First Friday Talks now. Alan Franzluper most of his research has been on pasture quality, soil carbon. He's also one of the leading scientists for the standardized methodology for greenhouse gas measurements in ARS, which is called GraceNet. And he's also the co-chair for the Croplands Working Group for the Global Research Alliance for Agricultural Greenhouse Gases. And that group is now developing really sort of global standards for measuring these systems. So he's currently working out there with some funds that I got for this project, and they're looking at the greenhouse gas exchange in the tree system at the margin and in the crops. Janet Chappelle has just finished her collection for some of these and is beginning to synthesize them for her master's. And the indications are as you'd expect, reduced nitrous oxide emissions from these systems. We have to look a little bit more at the seasonality and other issues before anything definitive can be said on this. But getting back to the civil pasture thing, we know that the bottom line dollar for the farmer is determined by that improved feeding, take, weight gain, milk production, improved animal condition for sure, and improved breeding efficiency of these systems. NCA and actually several other climate change documents out there have pretty much put as number 2 that livestock will be facing these thermal environmental challenges. That one option is to start establishing versatile alley cropping systems to potentially go into civil pasture. And again, that's another project that we have Evan and Greg Fry at the VSU working on, the economics of it. Proactively putting these systems in place because they take some years to establish and see what happens under these erratic weather events.
Hey, Michelle, can you just go back to that?
Sure.
Can you explain the improved breeding efficiency from the microclimate thing?
Oh, yeah. And this is actually more from the research that's done in Europe, in probably the northern plains. Protection, wind protection during calving, birthing, lambing.
Breeding, I see.
Yeah.
Gotcha.
No, they don't like to hide in there. Nah, no, particularly with pines, that just doesn't work. It's the survival in that. Actually very, very important in Europe. Very important here for lambing season, and important in calving when you get that weird winter events that occur. So now, just to give you a perspective, move you out of the South, take you back to that mighty Midwest that I live in there. I now want you to think outside the box. And I never tell a cat about that. I do volunteer at a cat shelter. Let's rethink our tools. You know, quite honestly, Forest Service has such a treasure load of research. We can do research. Really look at what we know about these systems and reconstruct management guidelines. And with agroforestry, think about it. Frequency and levels of flooding are predicted to increase under projected climate scenarios. Loss of crops and degradation of land affecting subsequent production is going to increase. And while we need to we can't control this first one, maybe we can control that second one. So think about these lands. Why not, instead of a windbreak, use a water break? Same principle, you're breaking the power of the water. Essentially have your primary water break that really sort of reduces the amount of damage coming into the fields, and that's really where a lot of the economic damage is what's deposited on there, as well as scour, tremendous scour in the 93 floods. And then you have these perpendicular ones that again dissipate the flow and the debris. Do you have these just as water breaks? No way. Farmers will not do that. You can't ask them to really do that either. Back to flooding services you would get from it though. Protections of levees breaching, essentially keeping that line drier on the water side so that when they are saturated, essentially the levees do not collapse. We found that in Missouri and Kansas during the 93 situation. Increase that bank stability, increase sediment deposition off-site, I should have added. Reduce gully creation, you saw that in that one event when the floods pulled away and trapped debris. These are what are important. Increase wildlife habitat. Midwest-Vaco, when they were in Paducah, set up a bunch on the Missouri and Mississippi River floodplains, in a sense essentially hunting leases in these areas. So they would essentially grow the crops and do designer corn, soybean. As the trees grew up, they would put in buckwheat. Buckwheat for what? Track that wildlife. Hunting leases, essentially grow them up, harvest them. Enhance water quality, protect soil quality, and provide those alternative incomes that I mentioned. While these are in place doing those things, the climate change services are protecting the ag land, building the resiliency, reduce risk by diversification, probably knock out an annual crop, but you still have that investment in the longer term. Sequester greenhouse gases, including the carbon, reduce greenhouse gas emissions, and provide that refugia for biodiversity. So I took a quote from Hatfield and Sauer, two ARS scientists there at the National Laboratory for Agriculture and the Environment. The next revolution in agriculture won't be the result of any single factor, but a resilient production system capable of coping with any number of stresses. And if you go back to that original list I had, it's really going to be providing a landowner or a land manager with a big menu and with guidance on how to assemble them. And that's really it for the talk.